This is the video tutorial for lesson 3.6, which is perpendicular lines. And what you can see on the first slide here is an example of perpendicular lines. So perpendicular lines are two lines that make a slope, that have an angle, of 90 degrees between them. Now, the key fact to notice just from this first picture here is if we look at the slopes, first thing we can see is clearly they're not the same slope, which is what we had when we had parallel lines. But notice the numbers are very similar. And actually, that's the connection between these two slopes. The phrase is opposite reciprocal or negative reciprocal, or often, as we like to say in class, flip and change. So if you flip this fraction 4/3, notice it becomes 3/4. And the change is the change the sign. So if it's negative, it becomes positive. Or if you do it the other way around, if you flip this one 3/4, it becomes 4/3. This is positive, and then change it to negative. Now, there is a little warm-up activity that you can try, very similar to the one we did before. Just a reminder that when we're trying to find slope, as long as it says y equals, we're looking for the number in front of the x, or how many ever x's we have. So when it says x, it's just 1x. And I'm going to let you complete that one by yourself. And there's a chance to have a little practice on the point slope formula, which we've been using recently quite a lot, and we'll use again in this lesson here. So when we're trying to find the equation, particularly when they give us the graph for this, it says find the one that's parallel this time. We'll go back to the perpendiculars in a second. Parallel is going to be the same slope. So looking at my picture here, I can certainly see this point here and this point here. I can see that I go up one and I go right one. So I know that my slope is 1. And as I'm looking at my answers, I can actually see that some of these don't even have a slope of 1. This is -1. This is 8 and -8. And this is -1. So I'm really kind of sure it's between these two as it is anyway. And the coordinate for this one, notice the scale here. It's not goes in ones, it actually goes in twos. So this is -2, this is -4. And actually the other value is +4. So this would be my x1, y1, and then you can use that point slope formula. Y minus y1 equals mx minus x1. Now, I'm actually going to do this question in a slightly different way, just for a little bit of saving time, but also to demonstrate the other way as well. As we know, the slope for this goes up 1 and across 1. If this is parallel, this must do the same. So this must also go up 1 and across 1, up 1 and across 1. And then checking the scale for this, I know this goes 2, 4, 6, 8, 10. And I would actually know that the answer for this, is that y equals x plus 8. So you should certainly practice using the formula because we're going to use that in class. But just for the purposes of this video, once you've used the point slope formula, you should end up with that answer. So the first thing we're going to look at today is specifically finding perpendicular slopes. And it's just the thing that we talked about a second ago. So it's the fact that we notice they are negative reciprocals of each other. And one other fact is if you multiply the two numbers together, then you're always going to end up with 1. There is one exception to that. If one of the slopes is undefined, or if one of the slopes is 0 for that matter, that won't actually happen. But in general, that will actually happen. Now, if we do have -1/3, you can sort of see how we could flip this and it would become 3/1. And then if we change the sign, it becomes +3/1. And remember to simplify those. So 3/1 would just be 3. Now, if we have a single number, we're going to do like we did for rise over run. We'd write 3 as 3/1. Then you can flip it to become 1/3, and you can change this positive into a negative to find out exactly what's happening there. And there are some examples here to show you how that would actually work. And I already noticed there's a mistake here straight away. For 2/3, the perpendicular slope is supposed to be -3/2. And that's just a reciprocal right now, not a negative reciprocal. -3/5, flip it, 5/3, and then change the sign. For 5, you would write it like we said earlier as 5/1. Flip it, so it's 1/5, and then change the sign. If it's 1/2, flip it, so it becomes 2/1, and then change the sign, but also simplify. I know it's a little small here, but on Desmos, -2/1 is indeed -2. Now, if you have a slope of 0, technically you could put that over 1 as well, 0/1, and if we flipped it, we would get 1/0, change the sign is negative, and it would actually tell you on Desmos it's undefined. Really, for the 0 slope, we just kind of want to think what 0 looks like. And then perpendicular would obviously be this, which is actually your undefined slope anyway. But just another way you can get around that problem. Now, the table we had from the warm-up, how we're going to use that in today's questions is when we're finding equations, we'll be given an equation like this. We'd have to work out what the slope is. Last time we did this with parallel lines, it was just the same number. So today, that's obviously not true. So 4, I'm thinking is 4 over 1. So when I flip it, it becomes 1 over 4. But I also need to change the sign, and it would become negative 1 over 4. Negative 1 over 5, flip it. So it's 5 over 1, which is actually just 5, and change the sign. So instead of being negative, this would actually just become positive 5. 1's a little strange. 1 would just be 1 over 1, but when you flip it, you still get 1 over 1, which is 1, and then you change the sign. So negative 1. And you can certainly try the other ones just to make sure that you do understand that process. Now, once we've got the idea of how to find that perpendicular slope, we can use that with that point slope formula that we're using in our previous lessons. So write the equation in slope-intercept form that passes through the point 0, negative 2, and is perpendicular to the graph y equals 5x plus 3. So the important part is we have a point here, which I can certainly write down and label x1, y1 as we did before. The slope here is 5, but as I'm doing perpendicular this time, I know I've got to do that negative reciprocal. So 5 over 1, flip it, 1 over 5, and then change the sign so it becomes negative 1 over 5. And then you can use your point slope formula to actually work your way through to the answer. Now, for this particular one, as this actually is the y-intercept here, because you can see the x value 0, as the y-intercept is negative 2, you could actually write the answer straight down as negative 1/5 x minus 2. That doesn't always work, which is why we sometimes want to check using that point slope formula. So y minus negative 2 equals that slope, negative 1/5. Now I put new slope this time rather than slope, just to show the fact that the slope of this line is 5, but I'm really interested in what's the perpendicular slope. I guess I could easily put perpendicular slope too. X minus 0. Now x minus 0 is just x, so I'm actually just going to leave it like this. The two negatives make a plus, and then as I bring this to the other side, you can kind of see the answer straight away. There it is. Negative 1/5 x minus 2. And like we said, we could have just written down the y-intercept for this one because that's the information they've actually given us. Now, there's one for you to try here. There are check boxes here so you can fill in as you're going along. So first one talks about what's the slope of this line, then what's the slope of the perpendicular line, and then after you've used your point slope, you can obviously do that. Once you have filled and found the perpendicular slope, make sure you fill it in here, and that will enable you to go and check the rest of your answer. Now, once you do have an answer as well, just remember in Desmos, you can actually type in the equation here and check, does it actually pass through the point? That's what the question's talking about. Find a line that passes through this point and is perpendicular to here. So once you found that perpendicular slope and you think you have the answer, I know there's a checkbox here, but that obviously wouldn't happen on a test. You could actually check your answer just to make sure that that is correct. And then there's a similar one here. 3/4 would obviously be the slope for this one. I'll do a little bit of this one. And then the slope, flip it, so it becomes 4 over 3, and then change the sign, so it becomes negative 4 over 3. And then you can use that point slope here with this number here. So not the original slope, but the perpendicular slope, and so on. Now, also, we had questions where they give us a graph and they ask us to find that information. And that's a little bit more difficult to do. So when they give us the picture, we've actually got to work out what the slope of this line is. So I'm kind of looking for some key points on here. There's one, and the y-intercept. Actually, they've given us a point on this graph, so we could actually just use this. So I can see that it goes up 1 and then goes across 3. So the slope is 1 over 3. Oops, I should check answer, of course. Perpendicular line, flip it. So it'll become 3 over 1, which is just 3. And also change the sign. So it'll become negative 3. And then we could go ahead and we could just use our paper and pencil. At this point here, I can see is negative 1, negative 2, negative 3, and then 1. So I got my point, negative 3, 1, which you can label x1, y1. I have my new slope, which is negative 3. And then I can use that point slope. If you need additional help on point slope, just remember to go back to the earlier videos in this unit to help you to do that. And there's one for people to try here. The point is actually given here. Just to make this a little easier, I did actually put the dots on the picture to help. So as I'm counting my squares, I'm thinking rise over run here. So I'm going down 1, 2, 3, 4, and then across 1. So negative 4 over 1, that would be negative 4. Perpendicular to that, I want 4 as 4 over 1, so when I flip it, it will become 1 over 4. I'm changing the sign, so originally it was negative, and now it's positive. And then using this point here, you can go ahead and use that point slope formula to check your answer. Sometimes it's a little more complicated when we have those horizontal and vertical lines. This one, I think you better not really write anything down. You better just visualize the problem. So we can see that, remember, the perpendicular lines are 90 degrees to each other. So I can see that this is going to be a vertical line straight away. But I also know I want it to go through this point. So if I was to draw in that vertical line, look, you can see the 90-degree angle here as well. Notice for vertical lines, I'm thinking of that word vux again, V-U-X. So I know it's the X value, and you can see clearly it goes through 1, 2, 3. X equals 3. There we go. So they're fairly easy to do as well. And the last part is sometimes we're asked to prove if something is parallel, perpendicular, or neither. So we're going to try that question as well. So determine if the line is parallel, perpendicular, or neither. And then we have two equations, and then we have those answer choices here. Now, I think personally the easiest way is to graph those two equations. And I've actually gone to the liberty of typing these in so you can see. Now, don't just look at them and go, oh, that's parallel, because sometimes they can be very close, but not the same. The homework for 3.4, I think, had slopes that were 3/4 and 2/3, which kind of to the naked eye look very similar, but obviously are not the same at all. So as I'm counting squares for this one, I can see that this one goes up 2 and across 1. And I can also see this one also goes up 2 and across 1. So as they're both slopes of 2, as they have the same slope, I know that they're going to be parallel. And same for the next one. If we actually type these in, we can have a look. Well, first of all, you can see straight away, these are clearly not parallel. If we look at the slopes for this one, I can see that it goes down 1 and then across 2. And this one here, this one doesn't really go through a corner of a square here. So I'm going to start from here. Let me just move my little picture out of the way here. It goes up 1, 2, 3, and then across 1, 2, 3, 4. So I've got down -1/2, and I got 3/4. Now, clearly, if I flip 1 over 2, I do not get 3 over 4. So these are not negative reciprocals of each other. They're certainly not the same. So for that reason, I can say that they're neither. They're neither parallel or perpendicular. I had one of that slope was -1/2, 1 over 2. If I was to flip it, I would get 2 over 1. So that's what I'm looking for if it's going to be perpendicular. I'd be looking for a slope of 2, and that picture clearly is not. And for the third one, same idea. They're already typed in. Clearly not the same slope. You can see that straight away. So this could be perpendicular. Let's have a look at the slope for this one. So it goes up 1, 2, 3, 4, and across 1. So 4 over 1 is 4. This one here goes down 1, and then across 1, 2, 3, 4. So actually they are negative reciprocals of each other, or opposite reciprocals if you prefer. Now the picture, you might say, well, that's not 90 degrees, but also notice in this picture, these are not actually squares either. So sometimes the scales change to stop you just from looking at the picture to see if it's 90 degrees. And that's why we actually need algebraic calculations as well to check if something is parallel or perpendicular. So I'm going to click perpendicular for this one, as it was a negative reciprocal. And for the last one, they're already typed in again. For this one, certainly they're not parallel. And actually, I can tell this is not perpendicular either, because these are both positive slopes. And I know one of them has to be a negative reciprocal. And clearly this is, or an opposite reciprocal. And clearly that's not true for this one. Let's just look at the slopes though to see what's happening here. This goes up 2 and across 1. So that's 2. This one goes up 1 and across 2. So actually 1 over 2, if I flip it, does become 2 over 1, which is this one here. And that's what sometimes people get confused with. They notice the reciprocal, but they fail to check, is it the opposite reciprocal, which this one is not. Therefore, this one should be neither. It's half of it, but it's got to be an opposite and a reciprocal to count as perpendicular. That's it for this assignment, for this exercise. It says go look for assignment 3.6. Just remember, you can also rearrange the equations algebraically if you like. If you want to work out what the slopes are, make them say y equals. This one here straight away, I actually knew the slope was 2 because it starts with y equals and I have 2x. For the other equations, we can rearrange them. And then once we have them in slope-intercept form, you can just look at the two slopes and then make a conclusion. So this was the answer to the first one we did. Here's the second one, and we remember those slopes of 3/4 and -1/2. That's how we knew it was neither. For the third one, we had the 4 and -1/4, which we said was an opposite reciprocal or negative reciprocal if you prefer. And for this one, the last one, we had 2 and 1/2. So just a reminder, it is a reciprocal, but it's certainly not opposite. So this would be neither. So if you prefer to do them algebraically, you certainly can. But I think the graphing one is a very nice visual because it eliminates the parallel one pretty quickly. And sometimes you can see straight away if it's not perpendicular just by the fact that if you have two positives, clearly they're not opposites. Or if you had two negatives for the same reason, they wouldn't be opposites either, so you know that they wouldn't be perpendicular. And that finishes it for this video. And remember, just go back and use the previous videos if you do need help on that point slope formula.